We had ended the previous video by asking this question. When we call a function and give it an array as an argument, why are we passing that array's base address? Why are we using pointers to pass whole arrays? So let me explain this with an analogy. So I want you to think of an array like a row of houses, right? So think of this black house as house 0 and house 1 and house 2 and so on. So let's say we're standing here next to this house 0 and we can actually see its address. It's written next to the house, and let's say that address is 1000. But suppose from where we are standing, we're too far away to see the actual address of the neighboring houses. But we know how houses are numbered typically along a road. So we know that if house 0 has address 1000, then obviously house 1 will have address 1001 and house 2 will have address 1002. And in general, if we want to know the address of house K, even if that's very, very far away, we have a very simple formula for calculating the address of house K. Now, this is exactly the idea that we're going to try and take advantage of. When we pass an array to a function, that function is going to want to do something with the various elements of the array. It may want to access the kth element and then something else, right? So how is it going to figure out the address of the kth element, where in memory it's living? Well, data in an array is laid out exactly in the same way that I'm showing you here. And so all that function needs to calculate where in memory the kth element lives is the beginning address, the base address. Once it has this, it can do this kind of formula. So this is exactly what happens. We have already seen that in a C program, when you have an array, the name X of the array is just this base address. It's a pointer to the 0th element in the array. Now it turns out you can take that address and add any number k to it, and it will give you the address of the kth element of the array. Now this is something called pointer arithmetic. We're taking a pointer and adding an integer k to it, and although this is adding different types of data, this is allowed in C. So this kind of pointer arithmetic is allowed, and it actually produces the address of the kth element. So this is what we're trying to take advantage of. We just pass the base address. When we call a function with an array, it's really just passing the beginning address, say 1000. And then when that function wants to access the kth element, remember that when we want to access this, we want to dereference this pointer, and the star and the ampersand cancel out. So when we want to do something with xk, that's just figuring out what this formula is and then following that pointer. So it's just a simple addition operation that needs to happen internally. As we will see on the next slide, it's sometimes a little bit more complicated than just addition, but this notation is what we call pointer arithmetic. And it's always the case that if I give you the name of an array and you add an integer to it, you get the address of the kth element. So this allows us to access any element of the array in some fixed amount of time. You just have to do this very simple arithmetic, and you know where the kth element lives, no matter how big or small the value of k is. You don't have to walk this whole street to figure out what the address of the kth element is. Just standing over here, knowing that the beginning house has address 1000, and knowing that you're interested in the kth house, you can immediately figure out what the address of the kth house is. Now I mentioned that sometimes it's not just as simple as adding. So let me explain that with another example. Let's say we're standing in this very, very fancy neighborhood, and they're not houses, but they are villas, which are, sort of stretched houses. So there's plot number 1000, but this house is so big that it actually occupies plot number 1000 and also plot number 1001. Right? So now you can see that, if you know this fact that these houses are really big and they occupy 2 whole plots. So if house 0's address is 1000, then actually house 1's address will be 1002. Right? I mean, I'm assuming the entrance is from here, and then this is just some extra part of the house. So the address is 1002. The house starts from 1002. Similarly, the data in memory in the array would start at address 1002, and so on. Right? We would have this kind of picture. So the general formula would now be something like this. If I want to know what the address of the kth house is, I would take the base address, and I would add k times however big a house is. So if a house occupies 2 plots, then the size of any one house will be 2. So this would be 1000 plus k times 2. And that's the formula that you could see applies over here. Right? Now, the nice thing is that exactly the same syntax is used. You can do x plus k in the C program, and it will correctly calculate the base address plus k times the size of an individual element in the array. Right? Now remember, we've just said the size of the 0th house, but we know that's the same as the size of a house 1 and house 2 and so on. Right? So this pointer arithmetic takes care of array element size. You just have to write x plus k. You just have to conceptually think of base address plus k, and you will always correctly calculate the address of the kth element, even though there's actually an addition and a multiplication going on. This is called pointer arithmetic, and it makes use of the fact that all the elements have the same size, and we know that that's true because an array always has the same type of data. All the elements of the array are of the same type, the type that you declared it. You said it was an int array, then every element is an int, and every int has the same size. If you said it was an array of type double, once again, every double has the same size. So because all the elements have the same size, it doesn't matter how big this number is, it's going to be the same for house 0 and house 1 and so on. And whatever that number is, we multiply k by that and add it to the base address, and that will give us the actual address of the kth element. But in terms of writing it, we just write base address plus k, and this syntax takes care of the multiplication by the relevant size. So arrays are very nice because all the elements are of the same type, and because of they are all of the same type, we can very quickly access the kth element. There are some cases where we need to have a structure that has data of different types. And for that, we will see that arrays are not useful, and we will actually consider something else, which we will see in a few videos from now.